Inverses are basically switching x and y. That's what you have to know. It's basically just switching x and y. If we have a relation, like right here, what's the difference between relation and function? Do we remember? What is a function? Like, what defines a function? Let's start with that.
Isn't it when you can put a straight line through the...
Pass the vertical line test. Well done. A relation doesn't necessarily have to pass the vertical line test. So relations just x's and y's. A function pass the vertical line test. So that's the only difference here. We're saying inverse relations, switch x and y. It may or may not be a function, or if you're reflected across that line y equals x, and a function, or inverses kind of undo each other. And we'll go deeper into that here in a little bit. Let's just start off with a real softball down the middle. Let's graph the ordered pairs. So the 0, 2, start with the x's, algebra 1, let's recall that. 1, 4, 2, 5, 4, 6, and 8, 7. All right, that's all we got going on. We're not connecting the dots, we're not doing any of that. Now if I were to switch my x and my y, so we're literally going to take my x's, put them down in the y's, and I'm going to take my y's and put them where the x's are. That's essentially what we're doing to find an inverse of something. We're just switching all of our x's and our y's. 2, 4, 5, 6, and 7. 0, 1, 2, 4, and 8. Yeah, if you're feeling super awesome, go ahead and graph this. All right, what do we notice about that? Do we notice anything? They kind of like cross. What else? What else? Anything about the shape? Anything at all? They both kind of curve. One kind of curves down, one curves up. So opposite curve. Kind of the same shape, just upside down. And then lastly, if I were to draw the line y equals x, and that's the parent function for a line, hopefully you remember what that looks like. It's reflected across that line right there. Right? If I'm all my blues and I were reflected, it makes all my purples and vice versa. How are we doing? Kind of basic, so are we okay to move on? Mm-hmm. All right. Let's complicate things just a little bit. On that number 2, you're going to graph all those points. Go ahead and get started. I'm waiting on a couple to finish. So go ahead and start graphing all of those. I'll catch up, I promise. Alright, so like I said, number 2, we're just graphing all his points. 0, -3, 3, 3, -1, -5. Got -3, -9. 1, -1. Alright, did I mess anything up? Let's kind of do that fast. Does mine match yours? Check me. Am I good? Okay. When it says graph f to the negative 1, what does that mean? That just means inverse. So what are we going to do to graph the inverse? Yeah, we're going to switch all my x's and all my y's. Let's go and connect our dots, by the way, for my red or whatever up there. It does say f of x, so we can go ahead and connect all those. That's cool to me. I like it. All right, so we're graphing the inverse. So instead of being at 0, -3, I'm going to be at -3, 0. Does my 3, 3 change at all? No. Then I got -5, -1, -9, -3, -1, 1. Connect all my dots once again. And I'm going to do one last thing here in a different color. I'm going to go ahead and draw the line y equals x here in green. So did it reflect across that y equals x? Did my red and my blue, is it kind of a mirror of each other? Yes, no, maybe so? Yeah, it is. Okay, so it asks if the original one. So the original one is my red one. Is that one a function? Does it pass that vertical line test? Yeah. So is this relation a function? Absolutely.
Oh, you've already passed them out?
Yeah.
Good, okay. Are there any ninth graders in here?
No.
Okay, we'll read it down in a minute.
Okay. All right, what's the domain? Where does my red dot start with my x value? What's the smallest x value for my red line? -3. So -3 to, where does my red line end x values? 6. Yes. Sorry, it's not very careful. There you are. Okay, range, going bottom to top, looking at the red. So what's our lowest value? -9. What's our highest value? 9. Bless you. How we doing? 1 to 10, give me a number. How we doing? 6, 7, 8, 9?
11.
11. Whoa! 11, I like it. 36, cool. Okay, now we're talking about the blue. So this is all the red function for me. Now we're talking about the blue one. So is that one a function? Does it pass the vertical line test? Yes, it does. What's the domain? -9 to 9. And what's the range? -3 to 6. Oh, there's a pattern somewhere. Look at the domain, and then look at the range. Look at the range, and look at the domain. Are they the same? They are. It's not a coinky-dink. All right, moving on.
Is it always going to be like that?
What do you mean always like that?
Like it'll always be the same.
Yeah, the domain for the original will be the range for the inverse, and vice versa. To the back. All right, we got 4 steps. Now we're doing this algebraically. The first step is to say, instead of writing f of x, we're just going to write y. So my first step is y equals 3x minus 1. That's my first step. What type of graph is 3x minus 1, by the way? Circle? Parabola? It's a line. Second step, if we're doing this algebraically, says to switch x and y. So literally, you're going to take what x is and what y is, and you're just going to flip-flop them. X equals 3y minus 1. The whole thing, we're just switching x and y. Next thing says to solve for the new y. So how am I going to get this y by itself? Add 1 to both sides. And I'm going to divide both sides by 3. This is algebra 1. We're solving for y. So divide that side by 3, divide that side by 3. So I get y equals 1/3 and then x plus 1. We ready?
Right.
Cool. However you want to do it. I said we're going to do it 2 at a time, but it's whatever. Whatever works for y'all.
Can I see a show of hands? Who is a ninth grader in class? I don't know what okay, that is fantastic.
Okay, so the last thing is that we're going to change, instead of writing y, we're going to denote that it's f to the negative. We're going to say that it's the inverse. So I'm going to say the inverse of x is that 1/3 and x plus 1.
This is 290.
The last thing they want us to do is to graph one in one color, one in the other. If you don't have 2 colors, don't even worry about it. I'll show you a trick in a second. Not a big deal. The first thing, though, we're going to do in black here. So y equals 3x minus 1. We start with the y-intercept at -1. And I'm going to go up how many and over how many?
29065.
Up 3 over 1. Good job. So 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. If you need a straight edge, like maybe your ID would work,
And calculator number is 2.
or if you have a pen that automatically corrects anything to a straight line, that works too.
Next.
Okay. The other one we're going to graph, instead of saying it's 1/3 x plus 1, it's kind of messy. So I can also say that it's 1/3 x plus 1/3.
Next. Eddie.
Why did you up 3 and then over 1?
Because the slope is 3 over 1.
Oh.
Are you new?
Okay, so I'm at this 1/3 plus, it's kind of messy, but it starts at 1/3, and I'm going to go up 1 and over 3. 1, 2, 3.
Mr. Van Cleve.
Yes, ma'am. Up 1 over
Can we
3.
see everyone who's got a calculator back up here, please? You'll need to write your ID numbers at the top of your sheet, please. Just up here in the top right hand corner, please write your ID number.
Howdy.
And then all of you guys, no, it's just this group, I think. Oh, that's fine.
No.
Okay.
Sir,
When you go over 1, how do you know you have to go right or left?
always go right, because we're always in positive. If it's negative, you go to the left. Okay. How do you know? Problem is that the y-intercept's 1/3, so we're starting like somewhere between 0 and 1, and then I'm just going up 1, kind of guesstimating, and over 3. The biggest thing is if I were to go back in here, draw the line y equals x, it's symmetrical across that. If you didn't have 2 different colors, you can maybe make 1 dash. You want to do that?
Wait,
Sir.
how did you, like, when you went up, how do you know where to start?
You start over
Next
this
table.
number right here. Go over there.
Next table. Well, we gotta go all the math classes first period, so y'all be ready to move.
Moving. All right.
Bring your ID.
Last thing.
What?
300422.
Solving for y. Here we're finding the inverse algebraically.
Yeah.
First step, rewrite it as y equals 2x. The next step, what are we supposed to do? Switch x and y.
Uh-oh, wait, it says. You're good. 29062.
And the last thing is just to solve for y. So what do I need to do to get that y by itself? Divide by 2 on both sides. So y equals, you can either do x over 2 or y equals 1/2 x. Either way, it's applicable. The last thing it said to do was to rewrite it instead of saying y, to use the inverse notation.
Next, ID.
So the thing in purple is the utmost final answer. We really need to get into a habit of rewriting everything with that inverse notation. Kind of went through that quickly. Any questions heard? Yeah, absolutely. You can do either one of those.
Next.
Oh, so you were getting X by
Next group.
Yeah, we're getting y by itself. What else we got? Any other questions?
ID.
All right, number 5. What's the first step? Write it. Y equals x over 3. Next step. Reverse. So x equals y over 3. And then multiply everything by 3. Is this easy? No, yes. So
Can you start going over, please?
right now. All right, it's y by itself.
Yes.
Yeah, if it's on the right hand side, we don't really like to look at that, but that's okay. We can switch it around. So y equals 3x. That's cool. Last thing, I need to rewrite it with that inverse notation. So it should be, I'll do it in purple again. The inverse notation, so the inverse of x equals. All right, y'all try number 6, please. Try number 6. You got the hang of it. So my first thing I'm going to do is rewrite it. Next thing I do is switch x and y.
Right, there you go.
Last thing I do is I solve for y. So I'm going to move 2 to the other side. So you get y equals x minus 2. Last thing, I need to be sure I rewrite it. Awesome. Questions, comments? Yeah.
Yeah. What's going on?
Oh. So instead of saying x 1/2 like that, that's just, yeah. That's just like saying we have half is 2, and then those 2 it's kind of off.
ID?
All right, number 7. A little tricksy, but still works the same way. So y equals negative 1/2 x minus 5. Switch them. What do I do after that? 9/5?
ID?
Mr. Banker, it doesn't matter what order you go in.
You need to be sure you add before you multiply or do anything else. Good question. I want to go get your calculator.
2906.
Last thing, since I have this negative 1/2 in front, I want to get rid of that. So I got to multiply by the reciprocal. Reciprocal is kind of like the opposite. We flip it.
What?
So what am I going to be multiplying by? 2 or negative 2, because I don't really like that negative there. So I get negative 2x plus 5 equals y.
ID?
I'm going to go get your calculator.
Next. Does everybody have one?
Last table right here. If you want to rewrite it, a couple of ideas there.
What?
You can go left to right.
Dina.
What property can we use there? Distributive property. So y equals negative 2x minus and negative 2 times 5. Yeah. Okay. Last thing, we write it as function notation.
Next ID? No, out of.
Alright, number 8, first thing, so I get y equals 4x plus 2 over 3. Hopefully we got that part. Next step, switch x and y, so I get x equals 4y plus 2 over 3. It's kind of a mess. Alright, next thing, what do? Some of y'all did it. I'll call that 3, so I get 3x equals 4y plus 2. Subtract 2. And then last thing, divide both sides by 4. So if your answer is, y equals that same thing, 2x minus 2 over 4, that's cool. Or you could say maybe something else. Anybody have something different? 0.75, or that's fine, 3/4 x minus 1/2 of 0.5. If you use decimals, that's cool, as long as they're exact. And then remember to do the inverse notation. That would be my final answer right there. No, it's just this is graphable, and that I don't really know how to graph that. Okay, number 9, the hardest problem on here. Y equals 1/3 5 minus 3x. Next step, switch x and y, so x equals 1/3 times 5 minus 3y. Now, I wouldn't distribute personally. I would get rid of this 1/3. So to get rid of that 1/3, I'm going to multiply both sides by 3. So that 3 cancels out, this 1/3 cancels out. So now I'm left with 3x equals 5 minus 3y. A couple people did that, I think. Next thing I'm going to do is get my y by itself. I'm just trying to isolate that variable, trying to get y all alone. Move 5. I'm missing something. What am I missing right there? The negative 3y still, right? We can't forget that. Last thing, divide by negative 3. So y equals 3x minus 5 over negative 3. If you want to actually show all your work and divide, that's going to be negative x plus 5/3. Reason why this is negative x plus 5/3. 3 divided by negative 3 is 1, that cancels out. Then I also have to do it by this one. So negative 5 divided by negative 3 is 5/3.